So a particle is projected from the origin O with initial velocity u. After 4 seconds, the particle has position vector 60i plus 25.6j. So when t is equal to 4, okay, it has position vector s 60i plus 25.6j. So in part A then it says calculate the distance of the particle from the origin after 4 seconds. So this is its position, 60 across, 25.6 up. So we want to get the distance. So remember now, okay, it's quite straightforward in terms of where it is. Well, we know it is sort of here somewhere, okay, and that is 60 across, okay, 60i means 60 across, and 25.6 in the vertical direction. Okay, so to get the actual distance, we want that length there, don't we? Okay, how far it is from the origin. So if I've got the horizontal and the vertical, how far it is from the origin, we're just going to use Pythagoras. So the distance will equal to the square of the two sides added. Okay, so the square of that, the square of this, add them together, and of course then you've got to square root it to get that length there. So we'll do that on our calculator. And it comes out to be 65.2. Okay, so that's what I've got there, 65.23 meters. B then says find the value of u given your answer in the form xi plus yj. Well, because we know this here, t is 4, s is 60i plus 25.6j, we can use s equals ut plus half at squared, just like in previous two questions. So 60i plus 25.6j equals to then u times 4 plus then half. Now remember, acceleration is going to be minus 9.8j, okay, as we discussed in the previous videos, and then time is 4, so 4 squared. So 60i plus 25.6j equals to 4u. Now if I work all that out there, so half times 9.8 times 16, and you get 78.4j. So take that over to the side, so I get 60i plus 25.6j plus 78.4j equals 4u. So 4u will equal to 60i plus then 104j, so that means then if we divide by 4, 15i plus then 26j, so that's the initial velocity of it. It says then in part C, hence then determine the minimum speed of the particle. So remember now, to get the minimum speed of the particle, okay, you just need to appreciate the component of velocities that we've got here, okay. The minimum speed will actually be at its max height, yeah, because this will not change, won't it? It will constantly go at 15 in the horizontal direction. The horizontal component never changes because gravity does not act in the horizontal direction, so it stays as 15i. So it'll be at its minimum when this is at its least. So this will be then 0, yeah, okay, in terms of its size. So we could say minimum speed occurs at max height, i.e. when the velocity in the y direction is 0, or the j component is 0. Okay, so min speed will equal to 15i, which, or rather the minimum velocity, I should say, shouldn't I? Will be 15i, so then the minimum speed then will equal to 15 meters per second. Okay, so make sure then you get rid of that I then, yeah, when you talk about speed, because I is talking about direction, isn't it? Okay, And we don't want a direction, we just want the size of its velocity, so we want the speed there, so we just say 15 meters per second there. Part 2 then, it says, the speed of projection of the particle together with the angle it makes with the horizontal. Well, we know that u is 15I plus 26j, so the speed of projection, we'll just be looking at those components. Okay, so we know it is 15 across and 26 up. So we can just use Pythagoras' theorem there, can't we? Okay, so we can create a triangle. Okay, because essentially it's going to be projected in that sort of direction there, and we're going to need to work out the angle there, of course. But you can create a triangle by going 15 across, 26 up, so the speed of projection will equal to, using Pythagoras, 15 squared plus 26 squared, all square rooted. So that comes to 30.02 meters per second. And then to get the angle of projection, well, you can use tan, can't we? Tan theta is 26 over 15, so theta then will be tan to the minus 1 of 26 over 15. So theta will equal to 60.02 degrees, yeah? So 60.0 degrees to 1 decimal place, or exactly 60. And we could say then above horizontal. So 60 degrees above the horizontal.